The chapter Ocean Coastal Processes and Landforms is a huge chapter, and so I'm going to go through some of the big ideas and then make sure you go over the reading guide and the goals and answer those questions before you take the quiz or the final exam. I want you to really be able to identify the littoral zone of a coastal environment. The book talks about how far up this zone uh, goes. It goes up into the highest wave and beyond. Um, what is the coast? What determines the beach? There's a section about wave mixing and how deep um, the seafloor needs to be so that the sediment at the bottom is not involved in wave action or wave mixing. And so make sure you review that. The book talks about average sea level and kind of know that term, and number of tides per year, that kind of thing. The book also talks about spring tides and neap tides and ebb and flow tides, and know this geometry between the earth, the moon, and the sun, and when does this geometry create a spring tide, and when does this geometry or the arrangement, the alignment, create a neap tide. Go over that. Also, know how many tides most places experience in a year, and then there's a discussion about some of the largest tides and where these are. This happens to be the Bay of Fundy in Nova Scotia, and you can kind of see the average wave height here in these curves on the rock, but the tidal area is about 8 to 12 feet here, or 50. I'm sorry, I was thinking of meters, but 40 to 50 feet tides in these areas. The book then goes into talking about waves and the difference between swells and waves, and kind of review this. Look at this kind of circular motion of a wave in deep water before it begins to touch bottom or touch the seafloor, and then as it begin, and the swell above it is relatively shallow, and as that wave oscillating wave begins to touch bottom, that wave tips, creating a more arced swell, and then as the wave gets closer to shore, the wave breaks, or that completely tips over. So understand that process. The other thing is this idea that as these waves travel across the ocean, they get refracted and they get bent and changed because of obstructions. And so here you have wave direction with the arrows, and then they're kind of bending and moving around these headlands. And so that what that does is create angular movement of the wave onto and off the shore. So here you can see these waves not coming in perpendicular to the shore. They've been refracted from that small headland. Here's another example of the waves coming in at an angle. And this angular motion of wave movement on the shore is what sets up the process of longshore current or longshore drift. And this is the movement of sand material or gravels up and down the beach coast. So the waves come in at an angle on the shore, but they come back into the sea zone perpendicular, and this creates this zigzag movement. There's a nice little video that shows that. So know how material gets moved up and down the shore, know the tidal processes, and then the two environments of depositional environments and erosional environments, and both of them have to do with different tectonic processes. So depositional landforms are basically seen on coast areas that have very low relief. These are not tectonically active. They're considered like trailing edges of the plate. And on these landforms, you're going to see barrier spits, tombolos, and very well-defined developed beaches. We have many pocket beaches in Oregon, but we don't have miles and miles of beachfront. So here's an example of a depositional landform. Know what that would be called. Here's a very long, I think this is in Cape Hatteras, very long beach environment, and you can see very gentle waves, pretty shallow, not a lot of action. Also be able to identify, well, there you go. You don't have to identify it at all. There it is. It's a tombolo. The other thing that you will see more of on depositional coastlines is you will see the development of river deltas. And the reason river deltas would develop here is that the wave action is fairly gentle and is not going to erode and move that material out into deeper water. So erosional landforms then, or erosional coastlines, are going to be seen in areas where there's more tectonic activity. And so you're going to have a very rugged coastline with lots of relief. These are called emerging coastlines. What you're going to see here would be sea stacks, sea cliffs, arches, and wave-cut platforms. So make sure that you can identify these aspects from the text. So you can see there's a really silly claymation of the creation of sea stacks that I put on the reading goals for fun. Wave-cut terraces and platforms are the result of the emerging coastline. So at some point, this platform or this step was down at sea level, got eroded, was kind of gravelly, scraped flat, and then lifted up above the sea level as tectonic movement lifted these plates or lifted those landforms up. So it's a nice example of a sea arch. A very active, rugged coastline, much different than that East Coast Cape Hatteras coastline that you saw. Here is a great erosional platform and a rugged coastline, and then more examples of stacks. So again, this is not an exhaustive lecture, but just some ideas to think about and help guide your reading and your studying.